Okay, so does anybody need stuff from last week? I'm running out. Sometimes you speak about it again. Yeah. Well, you don't need it. Just giving to those who didn't get it last week. Clarify people who didn't get anything last week. Okay. It isn't. Yeah. But if you lost it, but just to make sure that everybody's got it at some point. Okay. So, question 1. Does everybody understand the question? Perform the next pivot step. How would you know which pivot step to perform? Well, maximizing something, so you're looking for what is negative in the objective row. Okay, you see this is a negative number, so that tells you what is pivot. And then, how would you decide the pivot element? Least ratio. Well, the ratio is 2 and 11 is 3. That's 1 and 2. The least ratio is here. So the tableau you get will have x1 and x2 in the basis. Okay. And you should get 2, 1, 0, 5 over 7, minus 1 over 7 by just multiplying by 5 over 7. And you should get 1, 0, 1, minus 3 over 7, 2 over 7, and you should get minus 7, 0, 0, minus 1 over 7. Minus 4 over 7. Anybody confirm? Maybe. Okay. Now we didn't quite finish the.
We both have a positive one objective row.
So am I supposed to have a positive objective row? Yes. That's my common problem with getting this. Yeah, so thank you for pointing this out. Indeed, you should have a positive objective row. Apologies. I'm just taking last year's result, which well, we were doing the objective row in the wrong way. So, but consistently. So we're doing wrong then, it is wrong now. Okay. Yes. But for part, so this is just by pivoting. For part B, what it asks you to do is find it from the matrix without pivoting at all. And without pivoting at all, okay, what you need to do is the matrix of coefficients coming from the original LP, which is at the top here. So the coefficients you can see are 2, 1, 3, 5 in the linear inequalities. That's there. That's 2, 1, 3, 5. Now, when your basis is x1 and x2, which is the basis that we got here, okay, then the matrix MB that we called it last week is equal to A, so it's 2, 1, 3, 5. Okay, because the matrix MB was, well, you look at the basis and look at the first variable in the basis, so you take the corresponding column in A. And the second one is the second column of A, so what you get is just A in this case. Okay. So there's a slack variable, then you take the corresponding column of the identity matrix. This is how we get MB. And now you need to find the inverse matrix. So when you do this, either by hand, the way you learned last year, or by computer, you get 5 calculator. I think you can now even calculators can do inverse matrices. So you get 5 over 7 minus 1 over 7 minus 3 over 7 and 2 over 7. Okay, and this is, as we saw last week, this is what's supposed to be in the slack part of the tableau, and indeed it's there. So without pivoting, you can get this bit of the tableau once you know the basis. And if you want the val, you take the inverse that you have and multiply it by the right-hand side, the original right-hand side. So 5 over 7 times the original right-hand side of 5 and 11 in the example. So if you do this multiplication, you should get 2, 1. Which is the val. Okay, and if you want this part of the tableau where the decision variables are sitting, then you need to take MB inverse and multiply it by the matrix A. But because MB inverse is just the same as A inverse in this particular example, that can't be anything else than the identity matrix. And that's indeed what you can see in the x1 and x2 columns. And you had no idea how to do the objective row because we didn't quite finish the analysis last week. But we'll do that. Any questions? Make any sense? Just to reiterate, the idea of this exercise is that if someone gives you the basis, then without pivoting anything, you can work out what the tableau looks like by, yes, in this way. Okay? Good. Hopefully good. How about question 2? Does anybody understand the question? Oh, what's so hard to understand about this question? I asked this question of Killian, and he understood. It. He didn't give me the correct solution, but at least he knew what was. Okay, so Killian has 3 boxes with marbles. Okay, and they're closed. And one of them has red marbles, the other one has green marbles, and the third one has red and green marbles in it, a mixture. Now he has these labels: red on one of the boxes, and green on another box, and red and green in the third box. And they're correct. But now I came and I shuffled the labels on the boxes. And I did it in such a way that no label is correct. Okay, now what you want to do is, without looking into the boxes, take out marbles out of the boxes without looking. And depending on what you see on the marbles that you've taken out, you should be able to put the labels back on correctly. Okay.
The green label.
The question is, how many do you need to take out, at least, to be sure that you can put something back on? It's an easy question. I mean, it's not easy to solve. It's easy to ask and understand what it asks. Does everybody now understand what it asks? Do you want another week? No, do you want a solution?
Yeah.
Who wants another week?
You want to
I don't want to try it again.
They want to try again? Has anybody got any solution? Got any solution at all? Yeah?
Do you need to know how many marbles are in?
There are 100 in each.
Would you not only need to take out 2 marbles? Because if you take out the green marble, and it doesn't, obviously it's not going to have the green label on it, so it's not going to be the green.
So it's not going to be the green box.
It's
because all of them are incorrectly.
Yeah.
So if
Yeah.
the green marble comes out, it's not the green box.
Yeah.
So it's the red and green. And then the next one, you just pick out one, and if it's red, then it's the red box, and then the other one is the
not
green one. And then
the
if it's the
red
green
box.
one, then it's the green one.
Now I got lost in your solution. Okay, so you take a marble out of which box?
One of the boxes, because you don't know which one they are.
Okay. So you take a marble out of the green box, with the box labeled green.
Yeah.
Okay.
If it's green,
Yes.
Then the box should be labeled red and green.
Yes. If it's red,
Then it can either be
red or green or red, so
so you don't know anything. So what do you do then?
You choose a marble.
from a different box.
There's a second box, the one labeled red.
Yeah. Try the same process again.
Okay, if it's red, then it should be labeled red and green.
Yeah.
But if it's green, then you don't know anything.
But
So you go
know
to the
it's-
third box.
Yeah.
Which is labeled red and green,
That's
and you pull out a marble, and if it's green, then you know this box is red.
well, no, because if it's green, you know the box is green. Because the green, it
And it
can't
can't
be the
be-
mixture box.
It can't be the mixture box because it's already the
Actually,
one.
that's a good point. Take out the red and green. Take out a marble from the red and green box first, because you know it's not the mixture one.
Ah,
Yes.
So which, whatever colour the marble is whatever label
And then you only
that.
down to 2.
everyone's kind of lost.
And then wherever that label's coming from, has to be the opposite.
Yeah, so you only need one marble then.
Oh, you only need one marble.
Out of the red and green box.
Yeah.
Because once you know, they said take one out of
But they're all
Well, no,
incorrect, so you
because
just
the
swap
other
the
two
other two.
labels.
They're all incorrect.
Yes, they're all incorrect.
So you only need one marble.
Are you at 1 now?
So
Or are you still at 100? Okay, yes. So now, how do we summarize it? So you've got this red and this one which is labelled red and green. Okay. Take out one. If it's red, then this must be labelled green. Then you have the box which is labelled red and this which is labelled green.
No, if it's red, then the box should then be labelled red.
Oh yes. Take out is labelled red, then this box must be labelled red.
And the other two
Okay,
labels need
but
to
then
be
the red label, then the green label can't stay put on the box that's currently labelled green because we know that everything is labelled incorrectly. So the label from the green box has to move here. The red and green label has to move there. And if the marble you get is green, then this must be labelled green. But then the red label can't stay put, so it has to move here, and the red and green goes here. Yes, well done. Any questions other than what has it got to do with simplex? It has nothing to do with simplex, but it's a nicer question. So if you've got one, you can put two. No, you know what I mean. That's the number of exercises that you solve. Thank you. Does this look familiar? So what we did last week was what we've just seen in the homework exercise. And if I know what the basis is, B, I can work out what this matrix MB is. So I look at coefficients in the constraints and the identity, and I select the columns that correspond to basic variables. I do the inverse of this matrix, and then I get the top of the tableau without the objective row in this way. So in the decision variable columns, I get this matrix product. I get the inverse matrix in the S columns, and I get this vector in the val. And what we didn't do was the objective row. So that's what we're going to do now. Okay, this is a bit of a cheating a bit. So what is the not cheating at all? So what is the objective row in the first tableau? Oh, in the val column we have 0. in the decision variable columns, we have what?
11 on 5. Is it minus 11 or 11 on 5?
It's minus C.
Yeah, minus 11.
We do an example with 11. Oh, you lost everything. Okay, I remember things.
Oh,
And it's
oh, is that
0
from the-
in the slack columns, right? Now,
oh, it's minus 2 and minus 3. Isn't it?
okay, so what we get after pivoting is we're doing row reductions all the way. Okay, so what we're going to get is the original row, because we never multiplied or divided by anything, and to it we will have added a linear combination of these rows. Okay, that's what we're going to do. So does it make sense? Yes, it does. So so what we'll have is here there will be some R times NB inverse times B. And here we'll have the same R times NB inverse A minus C. And here we'll have the same R and the inverse. Okay, the reason is, as I'm saying, okay, so the final row is the original plus some linear combination of these rows. So you take multiples of these rows and add them to the original, and that's what you have there. Okay, and the coefficients of the multiples are hidden in this R. And we want to work out what this R is. So that's the idea. Okay, here we go. Yeah, well, that's it anyway. You don't believe me. Just say it again, write it again. It's this. And the last one is this. Now, so what is R? R is a row vector of coefficients to multiply the rows of the tableau. top of the tableau. Okay, well, coefficients of the linear combination. Well, this is because when you think about the pivoting process, so what you do is you start with some objective row, and what you're doing in each pivot step is add or subtract a certain combination of the other rows to it. And you keep doing this, and then in the end you've got the original row, which was 0 minus c 0, with a linear combination of the other rows added to it. And that's what is expressed in this formula. That's all there is. Okay? And what multiples of each particular row you have to take, that is given by this R, which is a list of as many numbers. Well, it has a vector really, but it has as many entries as there are rows in the tableau above the objective. Does that make any sense? So the step here what we're making is the mental step of jump between, you're adding various rows as we go, but we can ignore it. We can only think that we're actually looking at the rows at the end and add a suitable combination of them to the original objective, and that gives us the new objective. Because that is only possible because the other rows are again obtained by row reductions from the original rows. Okay? So we can just skip all the pivoting mentally and get this result. Except we don't know what coefficients to take. So this R is, we don't know what it's supposed to be. Okay? But we can find out. And the way we find out is similar to the way we found out what the matrix was last week. Okay? And so we start from the property that in the basic variable columns you have to have zeros. Okay, so there must be zeros in the columns of the basic variables. And which is a bit. I don't know how to display. Okay. I think I'll switch to this again for a bit. Not so hard to. Not so hard to. Try this tableau. Okay, so you have some tableau. Okay, you have some. Suppose you don't know what there is. Okay. You want to work out what is in the objective row. Well, you know that this matrix, you know what these are. Okay. Because that we found out last week. Now, you know that this entry here is minus 15, which was there when we started the tableau. But then you add some, you times this by R1, you times this by R2, you times this by R3. So what you get is, this is minus 15 plus R3. Okay? Because if you times this whole row by R1, you get a 0. Here you get a 0, and here you get an R3. You get the R3. Okay? So this entry is going to be minus 15, the original one from the first tableau because of the 15 in the objective, and a certain multiple of this one. And this entry here, second one, is going to be minus 20 because that's in the objective, so that was there when we started pivoting. And then we were adding and subtracting certain linear combinations of the other rows, and we're trying to find out what linear combinations. So it was this, R1 times 0 and R3 times 0, they'll count. And here in this entry, there was a 0 originally, and we added R1 times 1 and R2 times 0 and R3 times 0. Okay, and this entry, there was 0 when we started pivoting, and there will be R1 divided by 3 plus R2 divided by 3 minus R3 divided by 3. Because we multiply this whole row by R1, this whole row by R2, this whole row by R3, add them all together and add it to the 0 that was there to start with. Okay, that's what we do. Now, but we still don't know what R1, R2, and R3 we need to take to get the final tableau. But because we need a 0 here and there, they're the basic variables, that gives us the values of R1, R2, and R3 that we need. Okay, so because there are these zeros on here, we need, well, R1 needs to be 0. R2 needs to be 20, and R3 needs to be 15. Yeah? Because we want 0 there, there, and there. So this is out of the picture, but it says R3 over 3. So then you can check that 0 and 0 and 20 over 3 minus 15 over 3 is 5 over 3, and that's what is supposed to be there. So it works. But it has to work because that's what it is. So firstly, there are two ideas. The first idea is the one I said, is the objective row is what it was before we started pivoting. And to this, we add some linear combination of the rows, because pivoting does that, exactly that, adding linear combinations of rows to it. And the second idea that there is we can find out what linear combination of the rows by looking at the basic variables, because for the basic variables, we need the entries to be 0. This gives us the answer. Okay. Yeah. So from this, you can see that the R1 is there to make sure that there's a 0 there. And so it must be 0 because the first row is a slack variable. Now the R2, which goes with the second row, the basic variable in the second row is x2, and so R2 has to be 20, which is the coefficient of x2 in the objective to get 0 there. And the third row goes with x1, so R3, we have to multiply this 1 by 15 to add it to the minus 15 and get 0. Has everybody lost that? Oh, you shouldn't be. So following that explanation, because we need the zeros, we need R1 to be the objective function coefficient of the first variable in the basis. R2 of the second, and so on. Okay, this is how it goes. So I call it. The notation will be C with a little b. Okay, so this is the row vector which has exactly this. And then the objective row is this is what we get in the val column, and in the x columns we get CB and the inverse A minus C. Kind of complex formula. The last one is just a bit too optimistic. Yeah. But we would, Okay. Very quickly, let's have a look at the written example. So what this example is we've got some LP like this. I'm not going to read all the coefficients. And someone told us that the optimal tableau has the variables x2, s3, and x1 in the basis. We don't know how they found out, but let's say they claim that this is the optimal basis. And our goal is to try and find the optimal tableau, the whole of the tableau, just through this information. So, so what's the tableau going to look like? Well, the basic shape is there. There will be the objective row. There will be bases, values. We'll have x1, x2, x3, s1, s2, s3 like this. And there are three constraints with the stack variables. So we have three rows like this, and someone's claiming that x2, s3, and x1 is the optimal basis. So we can start like this. So when you're doing an exercise, when you want to find out what the other entries are, the first step is to work out here the right end. Okay, and this right end here is the inverse of the M matrix. And so what is the M matrix? MB. Well, the first column of this matrix, first variable is x2. So what I'm taking is -2 plus 1 minus 1. Okay? -2, 1, minus 1. The second column is S3. Well, S3 doesn't have anything there, but when you add the slack variables, it would have 0, 0, 1, because it could be there's plus S3 in the third constraint, and there's no S3 in the other constraint. So what you get is 0, 0, 1, and the x1 column is 3 minus 1, 1. Okay. Simple. Now, we do the inverse. Now, of course, probably nobody can do the inverse of this matrix in their head. I certainly can't, but I've done it, and it turns out to be, done it on the computer, turns out to be 1, 3, 0, 0, 1, 1, 1, 2, 0. Okay? Just take the usual inverse in MATLAB or in whatever you prefer. And this is the matrix that you find here. So 1, 3, 0, 0, 1, 1, 1, 2, 0. Now, the val is you do, by the formulas we've derived, you do this inverse multiplied by 1534. Okay, so multiplied by 1534 as a column vector means it's the same as taking 15 times this column, 3 times this column, 4 times this column, adding them all together. So it should be 24, 7, and 21. I think it is, yeah. I'll have to check. It's gone. 24, 7, 21, yes. Good. And now, okay, to get this bit, you take that matrix and multiply it by the original A matrix, which is quite a lot of multiplication, but I'll leave this as an exercise because I'm running out of time, and because I want to show you the objective row. So the objective row, when we look at the what we derived formulas, essentially what they tell us is, okay, for example, this entry, what we had was CB, MB inverse B. Okay, now MB inverse B we already know. MB inverse B is the column vector 24, 7, 21. Okay. That's how we got it. And CB is, I look at the objective coefficients of the basic variables. So x2 has -1. S3 has nothing is not in the objective, so its coefficient is 0. And x1 has 2. And 24, 7, 21. So what do I get? 18? Yeah, I think I get 18. And that is because, well, it's basically what it says is take -1 times this, 0 times this, 2 times this, add them all together, get 18. And the exact same process happens here. So we say -1 times 1, 0 times 0, 2 times 1 gives you 1. And here I think you get a 1 as well. -3 plus 4. And here you get 0, which is good because S3 is in the basis, so we had better get 0. Okay, now what remains is these entries. Okay, so I said this was MB inverse times A. If I just wanted this column, and I look at that column of A, 3 minus 1, 1, and I do 3 times, oh no, this one's boring, sorry, I want this column. This one I know where it's going to be because x1 is in the basis. So x1 is in the basis, I can fill it in. My x2 is in the basis, oh no, I want x3. x2 is in the basis, I know what the x2 column is going to look like. So the only interesting case really is the x3 column. And that one I get when I look at these coefficients in matrix A, 2, 1, 1 at x3. And I need to take 2 times this column, 1 times this column, 1 times this column, and add them together. So I should get 5, 2, 4. Is that right? And now this one, I have 2 different ways to work it out. The first one is that I'm going to take -1, 0, 2, -1 times 5, 0 times 2, 2 times 4 is 8, 3, is that right? -5 plus 8 is 3. 3 minus 1, because we started with -1, so 1 is the coefficient of x3. So I should get 2 here. Okay, does that make sense? Okay. This 2 is 5 times -1 plus 2 times 0 Because 4 times 2 take away 1. Where do they come from? Well, -1 comes from here, 0 comes from here, 2 comes from here, -1 comes from there, and 5, 2, and 4 come from here. Magic. I hope it's correct. Okay, the other way to do it would be, okay, I won't tell you. Would be 3 minus 1, 1. Here. No, not 3 minus 1. That's not doing it. I take these 2, 1, 1, 1, 2, 1, 1. I get 3, and again I have to take away this magic. Okay, that was a bit too quick. But this is how it works. Now we know enough to be able to do this exercise. So we've got an LP. I give you a basis. You should be able to write the tableau without pivoting in this way. Okay. It is in the handout I gave you last week, and if you haven't got it, come and pick it up. In the little kind of like chapters of the booklet, it is explained there. So if you want to read about it again, it's there. And the exercise I had for this week, for next week rather, I can't give you because we haven't covered enough in the lecture. So we have a free week. Any questions? Thank you.